Let's get started with the review. We are preparing for exam 3, and in these notes, notice that the Egyptian, Babylonian, Mayan, and Roman numerals are given. So you don't have to memorize these symbols, they will be given for you on the exam. Now let's start with question 1. We want to follow all the directions and show all of our work. Let's convert each of the following to our modern base 10 system. Question 1, we have 2, 5, 3, 2, base 6, and I want to convert this to base 10, which is our system. I need to remember the exponent starts from the right first as an exponent of 0. Then we have an exponent of 1, 2, and then 3. So we'll convert this to base 10 by writing the following. 2 times 6, since this is base 6, raised to the third power, since this is an exponent of 3, plus 5 times 6 raised to the second power, because that exponent's a 2, and this is a 5 down here, plus 3 times 6 to the first, and we're going to add 2 times 6 to the 0. So let's simplify each of these on a calculator. 2 times 6 cubed gives us 432. 5 times 6 squared gives me 180. 3 times 6, that's 18. 2 times 6 to the 0 should give me 2. Now we can add 432 plus 180 plus 18 plus 2, and this should be our answer. This is equal to 632, and this is in base 10, so we'll just leave it like that. This is our answer for question 1. For question 2, I'm converting from Mayan to base 10. So we'll start here at the bottom. This is equivalent to 1 in Mayan. This is a 5 plus 5 plus 3. So that's 13 in Mayan. This is a 5 plus 3 more. That would be 8 in Mayan. Now remember, in the Mayan system, they start from the bottom up. This is equivalent to 1 times 20 to the 0. And then this one's equivalent to 13 times 20 to the first. And remember, in Mayan, they have a modified base 20. This is 8 times 20 times 18. Remember, in the Mayan system, they don't do 20 squared. They do 20 times 18 because of their traditions. So we'll simplify this. Our answer is going to be equal to 8 times 20 times 18. That's equal to 2,880. And then we'll add 13 times 20. That is equivalent to 260. And then 1 times 20 to the 0 is 1. Let's add these values up. Adding all of this up, you should get 3,141 in our base 10 system. So double check your work. Make sure you can add all of this up and get 3,141. In question 3, let's convert 22,653 to Babylonian. Remember, Babylonian is a base 60 system, so we'll have to convert it to base 60. Now 60 to the 0 is equal to 1. 60 to the 1 equals 60. 60 squared is 3,600. And 60 cubed is 216,000. That is way too big. So I know that I am going to go up to 60 squared. That's the largest power of 60. that can fit into 22,653. So let's divide 3,600 into this number 22,653. The closest I can get to this is 6 times. So let's multiply 6 times 3,600. And that's equivalent to 21600 here, or 21,600. And then I will subtract. This gives me 1,053. And now I'm going to use 1,053, and I am going to divide the next power of 60, which is 60 to the first. So we'll divide this by 60 now. And this goes in there 17 times. That's the closest I can get. 17 times 60 is equivalent to 1,020. We will subtract. This gives me a remainder of 33. And so now we can write our answer. We have 6, 17, and 33. So what does this thing represent? Well, this says 22,653 is equivalent to 6 times 60 squared plus 17 times 60 to the first plus 33 times 60 to the 0. Now, how do I write this in Babylonian? Well, I have to write a 6, leave some space, write a 17, leave some space, then write a 33 in Babylonian. So let's write a 6 in Babylonian. That's 1, 2, 3, 4, 5, and 6. That's 6. Now we'll write 17. That's a 10. And then we'll write 7. 1, 2, 3, 4, 5, 6, and 7. Now we'll write 33. That's a 10. That's a 10. Another 10. That's 30. And then we'll write 3. And here's our solution. 6, 17, and 33. This is our answer in Babylonian. So we know there is 660 squared, 1760 to the first, and 3360 to the zeros. We converted from base 60 to Babylonian. Question number 4, let's write 1984 to Roman. And the way I want to do this is let's break up this into 1000 plus 900 plus 80 plus 4. That's equivalent to 1984. Now what's 1000 in Roman? That is the M symbol. How do we write 900? That's 1000 minus 100, so that's CM. How do we write 80? Well, that's equivalent to, how do we write 80? Well, that's equivalent to 50 plus 30, so L is 50, and 30 is 3 x's. Now, how do we write a 4? Well, that's going to be IV, because it's on the left. We'll subtract from 5, 1, so that gives us a 4. So this is our solution, M, CM, L, X, 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 IV. Now you don't need those spaces in between. You can move it a little bit closer. These are just for your notes so you can tell where these numbers come from. Question 5, let's use scratch arithmetic to perform the following operation. Recall base 5 has 0, 1, 2, 3, 4 as the only acceptable symbols. So if we go above 4, we'll have to put a scratch and then figure out what the remainder is. 1 plus 4 is 5. We'll put a scratch. 5 divided by 5 is 1 remainder 0. So we'll put a little 0 down here. 0 plus 2 is 2. 2 plus 1 is 3. 3 plus 2 is 5 again. We'll put a scratch, and I know the remainder is 0. We'll bring down 0 here, and since we have 2 scratches, we'll carry a 2 over. 2 plus 4 is 6. I'll have to put a scratch. 6 divided by 5 is 1 remainder 1. So this has a 1 as a remainder. 4 plus 1 is 5. We'll put a scratch. 1 plus 4 is 5. I'll put a scratch. And we know 5 divided by 5 is 1 remainder 0. So we'll put a 0 here. 3 plus 0 is 3. And then 3 plus 2 is 5. We'll put another scratch. And I know the remainder for that would be 0. 0 plus 4 is 4. So we'll put a 4 down here. And how many scratches do we have? We have 1, 2, 3. So we'll carry the 3 over. And this is 3, 4, 0, base 5. Again, as soon as we get above a 4, we'll have to put a scratch and write down the remainder in the corner. And for each of the scratches, that's what you carry over to the next column. Our solution is 3, 4, 0, base 5. Question 6, let's use the lattice method to multiply 5, 6, 7 times 8, 3. And it looks like this is base 10, so we can easily check our work with a calculator. But remember, the direction says use the lattice method, and that's what we need to do for full points. So we'll write 5, 6, 7 here on the top. And on the side, I'll write 83. We'll draw our rectangles. And don't forget your diagonals. Now we'll multiply. 5 times 8 is 40. Put a 4 and a 0 here. 6 times 8 is 48. We'll put a 4 and an 8. 7 times 8 is 56. We'll put a 5 and a 6. Then we'll do 5 times 3, that's 15. 6 times 3, that's 18. 7 times 3, that's 21. This becomes a 1 down here. 6 plus 2 plus 8 is 16. We'll put a 6 and we'll carry that 1 over. 1 plus 5 plus 8 plus 1 plus 5, what does that give me? That gives me 20. So I'm going to put a 0 here, and I'll carry the 2 over. Then we'll add 2 plus 4 plus 0 plus 1. What does that give me? That gives me 7. And then we'll bring down that 4. So here's our solution. We'll have to write it clearly. This is equivalent to 47,061. Now you could always double check with the calculator, but remember you have to use the lattice multiplication method to get full points. For number 7, let's add 2142 base 5 plus 433 base 5. The only symbols that I can use is 0, 1, 2, 3, and 4. 2 plus 3, that's 5, but 5 does not exist. We'll convert it to base 5. That's 1 remainder 0. So I have a 0, and we'll carry that 1 over. 1 plus 4 plus 3 is 8, but 8 does not exist, so we'll convert that to base 5. That's 1 remainder 3. We'll put a 3 down here, and we'll carry over a 1. 1 plus 4 is 6. 6 does not exist, we'll convert that to base 5. 1 remainder 1. Put a 1 here, and then we'll carry that 1 over. 1 plus 2 is 3. And don't forget your base here. This is base 5. Our solution is 3, 1, 3, 0, base 5. Question 8. We're doing subtraction here. We have 1, 0, 1, 0, 1 base 2 minus 1, 1, 1, 1 base 2. The only symbols I can use is a 0 and a 1. So let's do some subtraction. 1 minus 1, well, that's 0. 0 minus 1, I can't do that. I gotta borrow. So we'll subtract from this. That gives me a 0 here. And then we'll add back a 2. Remember, this is base 2. We're borrowing a 2. We're not borrowing a 10. So we'll add a 2 back. That's going to give me a 2 minus a 1, and that's 1. Again, I cannot subtract 1 from this 0. We'll have to borrow. There's nothing to borrow from this 0. So we'll have to borrow from the 1 first. This becomes a 0, and this becomes a 2. Now we'll borrow from that 2. This becomes a 1. And we'll have to add that 2 to here, so we'll add 2 to it. And then we'll subtract. What's 2 minus 1? That's 1. And 1 minus 1, that gives us a 0, so we'll leave that alone. So here's our solution. 1, 1, 0. Don't forget the base. This is base 2. Question 9, I'm going to use the standard algorithm first, and then we'll use the lattice algorithm. For your exam, feel free to use any method that you like to get question 9 correct. Now you have to show your work, but you can use any method you like. Let's use the standard algorithm first. What's 3 times 3? Well, that's 9. 9 does not exist in base 4. That's equivalent to 2 remainder 1. Again, the only symbols for base 4 is 0, 1, 2, and 3. I'll put a 1 down here, and then we'll carry the 2. 2 times 3 is 6. 6 plus 2 is 8. 8 does not exist in base 4, but I know that's 2 remainder 0. Put a 0 here and carry the 2 over. 1 times 3 is 3 plus 2 more, that's 5. 5 in base 4 is equivalent to 1 with a remainder of 1. So we have a 1, and then I'll carry that 1 over. So we multiplied everything with the 3. Now we'll eliminate our numbers up here, and then we'll do it again. 2 times 3 gives me 6. 6 does not exist, base 4. We'll convert that to 1 remainder 2. So we'll have a 2 here, and I'll carry that 1 over. 2 times 2 is 4, plus 1 more, that's 5. I know 5 is 1 remainder 1. Put a 1, and then carry that 1 over. 2 times 1 is 2, plus 1 more, that's 3. 3 does exist, so that's perfectly fine. We'll put it down here. Then we add. I have 1, 2, 2. 1 plus 3 is 4, but 4 does not exist. I know that's 1 remainder 0. Put a 0 and carry the 1 over. This is it. Our answer is 1, 0, 2, 2, 1, base 4. That is using the standard algorithm. Just for fun, let's use the lattice algorithm for question 9. To use the lattice algorithm, I'll write 1, 2, 3. and 2, 3 here on the side. Remember, we're still in base 4. We'll draw our diagonals. And we'll multiply. 1 times 2 is a 2, so we'll put a 0, 2. 2 times 2 is 4, but I know 4 is 1, remainder 0. So that's equivalent to 1, 0. 3 times 2, that's 6, but I know that's equivalent to 1, remainder 2. 1 times 3 is just 3. 2 times 3 is 6. I know that's 1, remainder 2 from the previous work. 3 times 3 is 9, but 9 is 2, remainder 1. We'll put a 2 and a 1. We'll add our diagonals. This is a 1. Then we'll add 2 plus 2 plus 2, that's 6. But remember, 6 is equivalent to 2, or a remainder of 2, and we'll carry that 1 over. 1 plus 1 plus 1 plus 3 is 6, but I know that's a remainder of 2, and we'll have to carry that 1. 1 plus 1 plus 2, that's 4. But wait, I made a mistake. 4 does not exist in base 4. 4 is equivalent to 1 remainder 0. So this is actually a 0, and then we'll carry that 1 over. So here's our solution. 1, 0, 2, 2, 1, base 4. So no matter how you do it, either the lattice or the standard algorithm, make sure you get the same answer. We'll have to multiply 3 base 5 times all of the numbers in base 5. 3 base 5 times 0 base 5, that's 0. 3 base 5 times 1 base 5 is 3 base 5. 3 base 5 times 2 base 5 is 6, but 6 does not exist in base 5, so we'll divide that by 5. I get 1, remainder 1, or 1, 1 base 5. 3 base 5 times 3 base 5 is 9. 9 does not exist in base 5. That is 1 with a remainder of 4. So it's 1, 4 base 5. 3 base 5 times 4 base 5 is equivalent to 12, but that doesn't exist. We'll convert that to 2 with a remainder of 2, or 2, 2 base 5. We'll finally do the long division. Let's do 3 base 5 dividing into 2, 3, 4, 2 base 5. Now 3 does not go into 2. You can put a 0 up here or leave it blank. Now what's the closest I can get to 23 in base 5? Well, that's going to be 4. So I'll put a 4 here. What's 4 times 3? I know that's 2, 2 base 5. We'll subtract. I get a 1. Bring down the 4. What's the closest I can get to 14 base 5? Well, that's 3. Put a 3. 3 times 3. Hey, that's 1, 4. So we'll put a 1, 4 here. Subtract. I get a 0. Then I'll drop down the 2. Now, what's the closest I can get to 2? Well, the closest I can get to 2 without going over is 0. So we'll put a 0 here. 3 base 5 times 0 base 5 is 0. So we'll subtract. I get a 2. And that's going to be our remainder. So let's make sure we write our answer correctly. Our answer is 430 base 5. With a remainder of 2 base 5. Or you could write your answer like this. It's the same thing. 430 base 5. Remainder 2 base 5. This is equivalent, so don't worry about it if you use a different notation than I do.